Welcome back. In this video, we are going to look at a few more details of the Lia language. Before we begin though, a few words about the IDE. You can change the font size by holding down Control and scrolling the mouse wheel up or down. Doing this when the mouse is in a text editor window will adjust the text editor text size alone, while leaving other UI text the same size. The IDE also has a dark mode. To switch it on, go to the IDE configuration form by using the gear icon at the top right. Under the Appearance tab, there is a checkbox to switch on dark mode. There is currently no facility to customize the various colors in light or dark mode, but this feature will be coming very soon. You also have the ability to choose the font used for the source code text editor. You can choose from any of the monospaced fonts installed on your computer. I'll switch back to light mode, and we can get started. Going forward, we want to use more interactive on-screen controls. To that end, I've introduced a simple touch handler interface that allows any control to capture and respond to mouse or touch events. The idea being that any control can provide a touch handler to the main app if it detects that a mouse press or touch event has occurred within its on-screen area. For example, I've created this button control, which will respond to a mouse click. It inherits from control base, which is just an abstract control that provides common default behavior. For example, the default behavior is to not respond to mouse or touch events. The button control overrides this behavior and provides a custom touch handler object if it detects that the touch event is within its area. So when the main application detects a touch or mouse press, it will now iterate through its list of controls and ask each for a touch handler object. The first control to provide a non-null touch handler will be considered the active control, and all future mouse movements will be directed to it. Now, let's take a look at some code and see how Lia can make it more concise. This section here iterates through the controls to find the first one that provides a touch handler object. The first line invokes the startTouch method and saves the result in a constant. And then an if statement is used to test if the constant is not null. With Lia, we can combine this very common pattern into one statement. Within the condition of the if statement, we can invoke the method and then test the result using the expression is not null as, and then provide a name for a new constant. This pattern, where a new constant is declared using the as keyword, is used in many circumstances within an if statement, and if the condition is met, it will assign a new constant that will only be accessible within the body of the if statement. While this expression is clear, it is too verbose. So for this particular expression, there is a simple and clear operator that can be used, which is the equals greater than operator, or thick arrow, as I like to call it. Turning our attention to the body of the statement, we see that we do an assignment and then immediately return from the method. For simple statements like this, Lia allows you to combine the two using the expression return after. This effectively turns two statements into one, thereby removing the need for the curly brackets required for a sequence of statements. So removing all unnecessary code block brackets, we end up with much more concise and clear code. We can see that if no control provides a touch handler, we'll default to our previous ball dragging and dropping behavior. So the main app class has been modified so that when it is first resized, it calls a setupControls method. This method adds three special controls: a button control, which we've just seen, as well as a progress bar control and a line display control. We'll see these in action soon. These controls also override the window resize method, so they can adjust their size, position, and text size based on the size of the window. So if we run the application, we'll see the new controls on the screen. I've also adjusted the aspect ratio to be more square, so we can see more information as we test. We can see that the test button reacts to mouse presses, but does not actually cause any actions yet. We'll add that functionality in now. If we go to the button class, we'll see a special field that I've added called onPress that is of type async task. If we review the API, we'll see that it is described as an object that can start an asynchronous process and return a handle to that process. A handle is similar to a future in Dart or a promise in JavaScript, but is more useful. It has synchronous methods that can be used to pull the status of the process and async methods that can be used to wait on the result of the process. There's an abort method to request that the process be stopped. A getDoing method to get a description of what the process is currently doing. A getProgress method to get an indication of how far along the process may be. There's a method to check if the process is complete, and one to get the result of the process if it is. There are also a variety of wait methods that can be used by an async method to wait on the process in some way. A process is not required to provide any progress or doing information, nor is it required to service an abort request. A process need only report when it is complete and return an appropriate return value if it succeeds, or provide an exception if it fails. Going back to the button class, we can see that when it detects that the mouse button has been released on it, it will call the startTask method on the onPress field if it is not null. This returns a handle object, though we don't do anything with it. What we need to do now is to actually provide the button with an async task that it can start when pressed. So we'll modify the main app to provide that now by creating an async method. All running async methods operate within a Lia task object, and each task object is associated with its own handle object and a progress object. A handle is used by an external entity to monitor the process state, but a progress object is used by the process to report its state to external entities via its handle. So we'll acquire a reference to the progress object for the current running task and report that we are sleeping and that our progress is -1, which is used to indicate that the process is running but cannot report a percentage completion value. After the method sleeps for 1 second, it prints a message and returns. If this method is invoked via an async call, then its completion will also mark the completion of the task it is running in. And this will automatically prompt the task to report to its handle that it has completed successfully. There is no return value in this case, since the method is void. So let's attach this method to the button. So now we should note an important point. The async keyword, when used to invoke a method in a separate task, always returns a value. That value is a handle to the newly created and started task in which the method is running. Here, we assign the value from the async invocation to the constant named hand. We can see that it is of type handle. But our button requires an async task object, not a handle to a running task. So we'll put the keyword deferred directly after the async keyword, and then we'll see that it now returns an async task instead of handle. The deferred keyword tells async that it should not start the task running, but just prepare it to be run via a later call to start task. So if we were to call start task immediately after the deferred async call, we'll see that start task returns a handle.
But we won't do that now.
Instead, we will pass that deferred task to the button via the setOnPress method. We call setOnPress and give it the async task with the expectation that it will call start task on it every time the button is pressed. So let's save and run the application. When we press the button, we expect to see that a message is displayed in the console window after 1 second. And that is what we see. However, we will also note that pressing the button thereafter seems to have no effect. This is because an async task created using async deferred will be a one-shot async task. A one-shot async task will only start once, and additional calls to start task will simply return the same handle returned from the very first call, even if it is already completed. Changing the deferred keyword to the repeatable keyword will give us the behavior we want. With a repeatable async task, calling start task will start the process anew with a new handle. This has no effect on previous calls. They continue to run independently. And this is now the behavior we see when we run the application. Creating repeatable async tasks in this way is very common in Lia programming, but this syntax is a bit verbose. So you can use the @ symbol as a shortcut for async repeatable. And we'll see that it runs exactly the same. This syntax can also be used with blocks of code, not just with method invocation. I will create a block of code that prints a different set of messages. And because I preceded it with the @ symbol, I am able to pass it to the button as an async task. So now when we run the app, we'll see the new messages appear in response to pressing the button. Let's go back to our original task method. We'll extend it so that it now counts up to 100 after sleeping, reporting its progress along the way. And we'll reduce the sleep time to only half a second. Now, let's look at our progress bar control. It simply displays a text message on top of a green bar that indicates the value of the task progress field between 0 and 1. When that value is negative, it displays a moving fixed width block instead. It also has a method to update its progress and text value from a provided handle. So let's add a method that will monitor a handle and update the display at regular intervals for as long as that handle has not completed. This is not complicated. A simple loop running in an async block which updates the progress values until the handle reports that it has completed. Now let's go back to the main app, and we'll get the progress bar to monitor the handle for the task that runs when we press the button. To do that, we simply call the start monitoring method we just created and pass it the handle for the currently running task. Let's run and see what happens. Now when we run again, we get a more dynamic display when we press the button. But that countdown was way too fast. The reason for that was because I forgot to put in a call to sleep in the counting loop, so it went at full speed and effectively ended instantaneously. With that fixed, we get something that makes more sense. But see what happens if we press the button multiple times in quick succession. We get multiple tasks all competing to display their progress on the single progress bar, leading to a messy display. Let's correct this by having the button disable itself when it starts a task and then re-enable itself when the task is complete. So we'll introduce a Boolean field into the button class that will indicate when it is disabled, and modify the start touch method so that it returns null when it is disabled as well. Then we will modify the paint method so that it displays its text and outline as dark gray instead of black when it is disabled. And lastly, we'll create a method called disable to disable the button. We'll modify the press action code so that it sets the disable flag after starting the async task. Now, when we run the app again, we see the behavior we expect. The button disables itself. It will no longer respond to presses and, in fact, acts like it is not even there. But I don't want that particular behavior. I want the button to capture mouse events when it is pressed, but I don't want it to do any action while it is disabled. So instead of returning a null value for the touch handler, I will return an empty touch handler object using the empty keyword. An empty implementation of an interface fully implements the interface, but all the methods take no action and always return appropriate null or 0 values. So now we get the behavior that I want. Of course, at this point, the button only works once because we have not re-enabled it. So we'll start by modifying the disable method to be a bit more functional. Instead of having a separate method to re-enable the button, we will have the disable method return an object that will re-enable the button via the closes interface. This allows us to return an empty closes object, one that does nothing, in the case where disabled is called when the button is already disabled. I will also add in an optional message parameter to change the text displayed in the button when it is disabled. By saving the original message text in a constant, the closes object we return can reset the message back to this original text when it re-enables the button. Now we'll just modify the press action so that it disables the button and then calls the close method on the returned object after waiting for 1 second. So the button gets re-enabled after 1 second, but this is not what we really want. We want the button to be re-enabled only after the task is complete. For that, we will use the add closer method in the handle returned when we start the async task. The add closer method allows you to add any number of objects that implement the closes interface, and the handle will guarantee that the close method will be called once on each one when the task completes. If the task is already complete, then the close method will be immediately called by the handle when it is added. So now when we run the app, we get the behavior we want. The button re-enables itself only after the task is complete. Please join me in the next video, where we will discuss more Lia features, including the use of namespace files to produce applications and libraries that have a flatter source code structure, similar to other languages.